Hello, everyone. Now, I'm not sure if you've ever experienced this problem before, but a lot of the times, if I'm going on websites like LLaMA and Hugging Face and all these different websites, I see a bunch of these different models like LLaMA and Mistral and Gemma, and I have no idea what model I should pick. Well, this video really goes over what would be the best possible model for text-based tasks. Now, I call it best in quotes because it's really not defined by any scientific study. I'm the person doing the study, and I call this the Amish criteria. Now, basically, what I did was I split the models into three distinct categories: a small language model, medium, and large models. Small models, anyone can simply run them on any computer, doesn't even need to have a GPU. Medium models are something which is like 600 to $1,000 laptop. And then large models are ones that people would usually have on something like a $2,000 plus laptop. And usually they have about 4 to 5 gigs of VRAM. What I wanted to understand was the performance of different models in terms of a lot of different factors. So things like speed, how fast the model is able to give me an answer. B was inference. So really understanding not just the accuracy of the result, but also whether or not it was relevant to the question that I asked. Other things that I also looked at was versatility. So whether it's able to answer questions in coding, as well as in logical thinking, as well as in creative thoughts. So if you didn't want to know what that process was and just wanted the final answer, I have posted the answer or the winner in the description. So you don't need to watch the rest of the video. You can just simply look at the one in the description. If you actually want to understand the process and how I came to selecting this model, then follow along. So we'll first start by looking at the small language model tier. Now, these are models that can pretty much be run on any CPU or GPU. So they don't actually take a lot of resources to run. And if you don't even have a GPU, then this is the type of model that you would essentially want to run. So we'll start off by comparing the small language model, and this is only about 229 megs, to Qwen 2 0.5 bill parameter, which is about 400 megs. And we'll compare that to LLaMA 3.2, 1 bill parameter, which is a little bit larger. It's about 1.3 gigs of memory. So we do expect this model to be more performant. But let's take a look at how these models perform in a wide variety of different tasks. So after asking these models to solve a wide variety of tasks in abstract reasoning, in creative writing, in common sense and logic, I have concluded that the best performing model in this tier seems to be the LLaMA 3.2. Now, places where models like Qwen and small LM excel, Qwen 2 just kept making mistakes over and over again. In terms of its calculations, it kept making mistakes. In maybe giving some sort of reasoning ability, it kept making mistakes. In more logical problem solving, it was making mistakes as well. So it is a significantly smaller model. We did expect the LLaMA 3.2 model to do better, but the reasoning path that the Qwen model does seem to take does end up doing a lot worse. Now, in terms of one problem, which is the Aunt Augusta murder problem, all three of these models did fail. But LLaMA 3.2 did give a much more of a structured approach when it tried to give a solution to the problem. Now, in places where the small language model did excel, was it actually didn't do too well in solving some of the mathematics or reasoning problems. But in my personal opinion, I feel like the explanation for this specific prompt on entropy and thermodynamics and implications in everyday life, the small language model did one of the best jobs at explaining thermodynamics and also giving a lot more of practical examples and how it could be used or applied in the real world. So, in conclusion, I would say that yes, the LLaMA 3.2 or the with the 1 billion parameters is the best performing model in this tier. But if you just wanted a model, something like a model to give you some creative writing or those kind of things, not doing a lot of reasoning, then the small language model that's only about 360 million parameters, this one does seem to be quite performant. So in this tier, I would give the winner to LLaMA 3.2, but an honorable mention to small language model. The next category that I'm going to be looking at are going to be not small language models, but maybe models that are under 2 billion parameters. And my goal here is to really look at these models that can fit in very small GPUs. The main models that I'm going to be comparing here are the small language model, which is 1.7 bil parameters. So this is about 991 megs. I'm looking at Gemma 2. And the one that I have pulled is the 2 billion parameter, which is about 1.6 gigs. And then the Qwen 2.5. And the one that I'm looking at here is the one with 1.5 billion parameters, which is about 986 megs. So these are the three models. Let's compare all the performance for all three of these, and let's take a look at which would be the clear winner. So this is midway through doing some of the performance testing, and the small language model 1.7 bil parameter ended up crashing my computer. So it just ended up going on an infinite loop, and it just kept going or asking the same question over and over again. It just couldn't get to the answer of the optimization problem. So this is one of the models that I'm going to be taking out because it can't really perform, and you can see that it keeps crashing Open Web UI. When we look at the overall performance between Gemma 2 and Qwen 2.5, I would say that in terms of its relative performance, the Gemma 2 model does seem to pretty much stop like over here. You can see that. Let me know if you'd like to continue working on this. And there was another logical puzzle. Logic puzzle known as the Dreadsbury Mansion murder mystery. There was another problem here that also stopped answering, and there was a lot of times when the Gemma 2 model seemed to be going around in the right path, in the right direction, but it just would keep asking the user to a prompt to see if it's going in the right direction. Now, in terms of the overall performance for the Qwen 2 model, it actually was not that performant for some of the logical reasoning and complex logic puzzles. It was pretty good at solving or answering the question on the creative writing. So I think that in this tier, if you're maybe comparing the performance for Gemma 2 and Qwen 2, they're both pretty bad at solving logical puzzles as well as mathematics, reasoning, those kind of things. But in terms of creative writing ability, I think that the clear winner here would probably be Gemma 2, just because Qwen 2.5 model ended up taking a lot of random directions in its story, and a lot of those pathways didn't make a lot of sense. So in this case, I would say the clear winner is the Gemma 2 model. The next tier that I'm going to be comparing is the one that's around 4 gigs of memory. So the models that I'll look at are Phi 3.5, Nemotron Mini, and LLaMA 3.2. So LLaMA 3.2, which is about 3.2 billion parameters. We have the Nemotron Mini, which is about 4.2 billion parameters, and the Phi 3.5, which is about 3.8 billion parameters. So in terms of the size, they're all pretty much relatively the same size, and let's take a look at their performance. When it comes to doing things like explaining entropy, the Phi 3.5 model is definitely going to be a lot more elaborate. It gives a lot of examples as compared to the LLaMA or the Nemotron Mini model. So it is quite extensive when it's giving that response. So that's the first thing to consider. In this category, there's a very clear winner. It's the LLaMA 3.2 model. It is leagues beyond all the Phi 3.5 as well as the Nemotron Mini model. It really answers all of these logical problems quite well. When it comes to things like storytelling, it did significantly better than Nemotron and Phi 3.5. At first glance, you might look at the story that Phi 3.5 has read, but then when you start going towards the bottom of the story, there's a lot of like junk words and vocabulary, and it's not even spelling things correctly. You can ask it things for common sense and logic, and you'll see that even over here, the LLaMA 3.2 model knows exactly how to solve this problem, and it goes into a lot of detail when it's trying to solve this problem. Versus a lot of these other models, they're quite hit or miss. I think that for this specific category, there's going to be a very clear winner for LLaMA 3.2. Compared to all of the models that I have used so far, this has been the most performant. In summary, I would say that if you have the ability to host the LLaMA 3.2 model, then that's the one that I would recommend. If you cannot host the LLaMA 3.2 model, then the next best model alternative that I would recommend is going to be the Qwen 2.5 model. And in the next video, I'm going to show you how you can still host some of these large language models, including the LLaMA 3.2, which is the 2 billion parameter model, 4 billion parameter model. And I'm also going to show you how you can host a 70 bill parameter model without actually having a gaming rig or an expensive computer, with even something as small as like a Chromebook or a $200 laptop, how you can host some of these really large language models. Obviously, you're not hosting them on your computer, but I'm going to show you how you can still make use of them. So stay tuned. If you're new to this channel, then if you could hit a like, a comment, a subscribe, that would really help the channel out, and I would really appreciate it. If you have any ideas or recommendations for future videos, then please leave me a comment. And with that being said, thanks for tuning in, and I'll see you in the next one. Goodbye.